First of all, let's remind ourselves of quadratic equations, because you remember how I was saying all polynomials can be factorised down to at least quadratics. So being able to solve a quadratic is a very important skill indeed. And it comes from, comes from the basic idea. If you've got two things multiplied together to give 0, one of those things has to be 0. There's no other way you can multiply things and get an answer of 0. So this is why we always factorise, because then once we've factorised it, we've got two factors, and we're saying, well, one of those factors must be equal to 0. So multiply together to give 18, add together to give 9, 6 and 3. So either the x plus 6 is 0, or the x plus 3 is 0, giving us two possible solutions, x is negative 6 or x is negative 3. So that was our basic idea of a quadratic equation. I point this one out just to highlight something. It's amazing how often when you see an equation like this second one, people forget to put down the solution x equals 0, because it's just sitting by itself. So, oh, it's not in parentheses, I won't worry about that. But of course, x equals 0 is a solution to that particular equation. So be careful with that. Now, not all can be factorised, as you know, and hence we have a lovely formula which allows us to solve them. As I was saying the other day about patterns. Where the formula comes from is because someone looked at it and went, hang on, there's a pattern here. I'm doing the same thing every single time. So rather than do this every single time, let's create a formula. And this is our formula, x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. Beautiful formula, isn't it? Lovely. All right, so we get an equation like this, and we say, oh, what multiplies together to give not negative 4, but in this case negative 8, adds together to give 5, and you can struggle and go, oh, you can try all you like, but no, can't come up with numbers for that one. And I suppose even if there was possible numbers, if you're spending too much time thinking about it, you may as well just go to the formula. I mean, it's going to get the answer anyway. So negative 5 plus or minus the square root of 25 and 32 is 57, and that's why we couldn't come up with those numbers, because we don't know what the square root of 57 is. So that really is the best we can do. 57, no, that doesn't simplify down. That, of course, is what we call an exact answer, and in mathematics we like exact answers. But if it is part of a practical problem, then often we will approximate to get some sort of an idea. So if the question asks us to approximate, well, to two decimal places, we have minus 3.14 and 0.64. So just see what the question entails. Normally you would leave it as an exact answer unless they ask otherwise. Making x the subject of something like this, we can still use the quadratic formula to do that. It's just that I've got a y there instead of a number. But y represents some number. So I can rearrange that and make it look like a quadratic equation. And all I do is include the y in the constant. So my constant now, instead of being negative 3, is negative of all 3 plus y. And so I just use my quadratic formula. Negative b plus or minus square root of b squared minus 4ac. C in this case is negative 3 plus y. And now I've made x the subject. That one does tidy up because I can factorise 4 outside the surd, but of course the square root of 4 is 2. 2 will then cancel. X equals negative 2 plus or minus the square root of 7 plus y. And what that basically done is, if you think of your parabola, because all quadratics when you graph them will be parabolas, it's actually describing the two halves of the parabola. One half is negative 2 plus, one is negative 2 minus, negative 2 being the axis of symmetry of that parabola. And so that's what we're saying, is all the x values will be symmetric around negative 2 in this case, when we were to draw the parabola. All right.